Hello everyone. Our article is based on energy router energy management control strategy in microgrid. I will introduce the work in the following aspects. As a key part of the energy internet, the energy router needs to achieve the purpose of distribution and balance of power, making the entire power system more safe and stable. This paper proposes several energy management strategies for energy router. Photovoltaic array is used as a basic power generation unit. Wind power is used as the auxiliary unit. The energy storage unit relies on the power balance through charging and recharging. At the same time, the maximum power tracking control and the constant power of the photovoltaic power generation system and the wind power generation system are carried out respectively. Consequently, with the development of large-scale integration of these renewable energy resources, distributed energy storage device, and the emerging DC load, the power network structure has become more and more complex. It also poses a big challenge to the conventional grid. Therefore, inspired by the development of smart grid and the information internet, many experts from various countries put forward the idea of creating the energy internet conception. On the way to the energy internet, current research work towards the energy router falls into these major categories. One is focused on the design and development of silicon-based solid-state transformer. Others study about the control strategy of microgrid. In this paper, energy internet and energy router topology concerning a PV power generation, a wind turbo power generation system, and the energy storage system is proposed. In the proposed energy internet system, the PV and wind turbo power system can either switch in maximum power point tracking control or in constant power control mode according to the demand of energy router. In order to release the energy management and control of energy router, the power proposed for operating stages control strategy and 6 energy management strategy according to the sunlight and wind speed to ensure the energy router to work in the optimal stage and utilize the PV and wind turbo efficient. For the mode and control for multi-port energy router system, the proposed multi-port control energy router topology is shown in the picture. It consists 4 ports, one for PV generation unit, one for wind turbo power system. These 2 units are connected to the common DC bus through boost converter and release MPVT and constant voltage control. The battery storage system, which is controlled by charging and recharging control, and release the power balance. The last port for the grid, which connects the DC-AC converter and the solid-state transformer. The whole MPC energy router system can release the energy recharge exchange to the grid, but also can release island running according to the demands. For the mode of PV system and control, PV is the main supply unit, which usually works in the MPPT mode, but in some special cases, It is required to switch to the constant power mode according to the system power requirement. The control system block of PV power unit is shown. The switching signal decides the operating mode of the system. For the control of wind turbo system, wind turbo power generation system works as an auxiliary power supply to support PV power generation system in case the PV and ESS can't meet the load demand requirement. As for the management control of the energy router system, in order to ensure the safe operation of the energy storage unit, it is necessary to monitor the SOC of the battery in real time to maintain the safe operating range of the battery storage. The purpose system topology provides the following features as the picture C. It also has full working states such as the renewable energy utilization rate is maximized and the excess energy is stored in the ESS. As for the energy router operating mode, it can be seen that the ESS plays a key role in the energy balancing. Balance the node in the entire energy management strategy. The core of the control system of the energy router, lies on the controlling each DG unit to work in the special operating mode by the energy management system. This picture shows the energy router operation, the 6 operating mode. To evaluate the effectiveness, feasibility, and the performance of the proposed energy management control method. The simulation mode is built in the Xuemei platform. The simulation parameters are shown in the table. The control algorithm of PV system is firstly simulated. To carry out the simulation of the disturbance activation method is adopted to implement the MTP control. The solar irradiance and the temperature variation are shown in the picture. And the picture C shows the PV system given power, and the picture D shows the switching signal of the PV system. Picture E shows the output power of the PV system after the switching is on or is off. As is seen in the picture E, from the time 0.5 second to 1.5 second, and the time 4 second to 5 seconds, the PV system works in the MTP mode, while during the time 2 seconds to 4 seconds, the PV system works in constant power mode. It can be seen from the picture B and the picture E. The PV system can follow the given power. This indicates effectiveness of the purpose PV system switching control. Next, the control algorithm of the wind turbo power system is evaluated. The results are shown in the picture. The picture A shows the input of random wind speed taken from the wind plant, and the picture B shows the speed ratio of the blade. It can be seen from the picture B that the optimal value is that the lambda is 8.1. The picture C shows the utilization coefficient, which can be kept as the CP is 0.425 for the wind turbo operate. at the MPPT control. Okay, in this part, the proposed 6 modes of energy router control are evaluated, uh, as we can see from the picture. According to the energy management rules proposed in this paper, both PV and wind power systems carry out the MPPT control. The SOC of the ESS gradually increases until the time 0.63 seconds, where the battery SOC reaches the upper limit of the LC. The further charging is prohibited. To the system power, the PV switches to the constant power mode and generates the 2 kilowatt between the time 1 second to 2 second period. The system is in mode 6. At the same time, the PV system switches to constant power control to maintain the 5 kilowatt power demand. Uh, it can be seen that the battery provides 0 kilowatt to the load. At this time, the PV can no longer meet the load demand. The PV switches to MPPT node to generation its maximum possible power, and the remaining power demand of the load is provided by the wind turbo generation system. It can be seen that the output power of the battery is still 0 kilowatt. The SOC is maintained at 18%. Between the time 3 second to 4 second period, the system is in mode 4. It can be seen that the output power of the battery is positive, which means that the battery is discharging to support the PV and wind turbo to meet the load requirement. Meanwhile, the corresponding battery SOC continues to decrease. Therefore, the system power is balanced and the energy management rules are satisfied. This paper first designed the energy router control strategy of the PV system and the wind power system, so that each power generation unit can ensure a certain amount of electric energy according to the command value. Then, the energy management strategy of the distribute power supply on the DC side of the energy router system is designed. Determine the work stage and output force of each power generation unit through the local judgment to achieve balanced flow of the power. Finally, the simulation mode is built in Xuemei simulation software to verify the switching of each power generation mode and the proposed energy management strategy. The simulation verifies the correctness and effectiveness of proposed method. That's all of my share. Thank you for your attention.